All right, thanks, Daniele. Yeah, and thank you all for being here. I know it's a little hard sometimes after whatever celebration you had last night to make it first thing in the morning. So why the interest in measuring irrigation usage on a regional basis? Could be in a county or a larger area. Primarily to aid in water management. We're kind of in a new era here in California with the Sustainable Groundwater Management Act. Prior to this, groundwater in many areas, unless you were like in an adjudicated basin, you could pretty much use water as much as you wanted without anybody needing to know that. But we're entering into a new era in many areas where we will have management agencies now in charge of that groundwater. So if you're the person who's actually having to manage that, you need some data to know how to assess what is going on. That's kind of one of your jobs. And to be able to allocate water effectively to make sure that you're not exceeding the limits of what that groundwater basin can provide. So some data would be very, very useful in that process. But I think this can also be an aid to farmers themselves, and I'll kind of try to show you how that might work. That if we have an idea of how irrigation is being used in a region, we can then assess ourselves and understand how we compare to how everybody else is using irrigation and maybe gain some insights from that. Because with groundwater pumping, if we were in areas where all of our water is being delivered by canals and we could see where that water is going and who is putting on water when, that wouldn't be an issue. But with groundwater, it's just simply all invisible to us. So being able to actually have some data that shows how it's being used can just provide insights into information that other farmers elsewhere already have without even thinking about it. And if you are in an area where, let's say, you move to another region and there's information like this that already exists and you have no idea how much to irrigate, could be sort of a starting point. If you have an idea of just what regional practices are, at least gives you some baseline on how to judge your own irrigations. Okay, so the scale of measurements that I'm talking about here taking, one could be a large region, say a county or part of a county. Incorporating many different operations. And the idea for this is to gain that baseline information for the industry. And then also data for agency use. So, for example, in my area, these agencies could be the groundwater management agencies in the future, but also we had the county governments that were heavily involved in trying to understand groundwater conditions in the area. They were paying for consulting companies to model groundwater conditions. So we needed some good data for those modelers to work with to make sure that the output of their modeling was as accurate as possible. So that was a lot of the inspiration for some of the work that I was doing before. You might consider doing something like this even just within a company, within an operation, to understand how your irrigation is being applied here. So to track your own practices. And one key thing here, within a large company, you might have somebody that you've hired to understand how to manage irrigation and to provide instructions to people. How do you know that those instructions have been carried out? By the end person down the line who has to turn the valves to get the water out into the field. This can be a good way to evaluate that. Is anybody here working as a consultant for another company? So if you're consulting for somebody, you might want to have your own devices that you're measuring what they're doing, so that way you have something to compare against. So that would be like some external entity here. Okay, so the question will come up, can we just ask growers how much water they're applying? And I think we did a question yesterday. How many people actually measure irrigation that they're actually applying? For a lot of people, that's something that they don't do. They don't keep enough records, perhaps, to be able to have accurate information that they can provide to somebody else. So if we're not actually measuring this, it's hard to be able to provide that to somebody else accurately. As I mentioned, there could be a difference between what your records say and what actually happened in the field, because for some things that you might not be aware of. So having independent measurements of what happened in reality could be very helpful to give us some better data. And automated measurements provide far more data than, for example, a grower might be able to tell us just at the end of the season looking at a flow meter to say this is how much was applied in altogether. So a lot of our automated measurements, these are little robots that are working all the time for us out there, taking measurements continuously, so you get far richer data and you can see far more things than you can just from looking at the flow meter at the end of the season. So some examples of how we can measure this type of information, just trying to get irrigation usage in a region. Well, flow meters are probably the first thing that would come to mind. If you're in an area where these are not common, though, they're quite costly to install to be able to get this kind of data. So they're have some limitations in that regard. However, there's a lot of growers who maybe not have had these in the past who are now installing them just for their own use. They themselves want to know how much water they're applying. One concern is that all of the pumping that may be going on might not all be for irrigation use. So if you're using water to wet down roads or in a winery or for some other use, landscaping or something, that's not part of the equation that we're looking at. A lot of times our goal is to understand what is the irrigation being applied just within the vineyards themselves. And typically, you're going to have a flow meter that serves a large operation, large number of acres, so you don't know where that water went within the operation. So if your goal is to understand within a certain block, say a certain variety, as a benchmark, it's hard to use this data sometimes to know how much went to that specific block. But otherwise, they're very good tools to have. Okay. Kind of related to that, you can estimate flows based on electricity use if you're using electric pumps. Provided that you have some type of smart meter or other tool, and that you know from a pump test how much electricity it takes to pump an acre-foot of water. Okay? So this is an example. This slide here, the picture comes from Powwow Energy, and that's kind of what they do in their work to turn electricity use for pumps into water values. How much water are you applying, and then track that for you. So again, though we run into the same problem, if this pump is being used for other uses, then we don't know how much of that was actually just vineyard irrigation. But otherwise, since this is already happening, you're already putting electricity into this pump, and hopefully you have a recent pump test value. If you don't, you can get one pretty readily, but then you can convert your electricity use into water use figures. So that's something that it's happening already. Another way to estimate water, maybe not quite directly irrigation, but at least water consumption on sites, is from satellite data. Now, I don't have a lot of background on this, but this is a picture of the Landsat 8 that is, I think, as Kapau explained yesterday, is flying over us continually every couple of weeks, zipping over at many hundreds of miles an hour, taking pictures all the time. Since this is already happening, maybe we can make use of this data as well to provide insights. So I just wanted to show you one example of how you can use this for free. Oops, it's the only one that I'm aware of. There's a website called Irrisat. So this is the golden tidbit of information I provide you if you're not familiar with this already. Irrisat, what it's doing, it's taking the satellite data from a number of satellites and converting it into very user-friendly values of estimated crop evapotranspiration for fields that you yourself can set up anywhere in the world. So it's a neat tool for free to be able to do that. So here's a field that I set up in my county, in San Luis Obispo County, and you can, like I said, it retains that in the system, its own memory. So when you log in, which you have to have a Google login to use this system, but once you do so, it just brings up whatever fields you have saved, and you can then go back in time for many, many years, actually, I think over a decade, and look at data, but it's updated automatically with the most current data. So what this current slide is showing you, this sort of shaded color here, is the crop coefficient based on this scale on the right, that KC value, and that's generated from the NDVI images that the satellite is taking in the field. So a pretty easy way, at no cost to you other than the time, to get some type of data showing what the conditions in the field are like. But there's more to it. Now from, say, a water use standpoint, if I clicked on this field, it pulls up a chart like this. And I know it's a little hard to see, so I'll zoom in on the next slide, but it gives you now some data over time of all the measurements that it's taking. And again, you can set this to whatever time you want based on the data that's stored in the system. So let me zoom in on the chart that's there. And this is the data then that it's providing. So I logged into this site yesterday, and so this is the current time right here on the right axis. And then what it's doing is showing you all the data from the past year. And so it goes back then to May of last year. So we're looking at a year's worth of data. And there's two things that are shown here. The bluish circles, that's the daily evapotranspiration that it's estimating from the field. That's why you see it's kind of high to the left back in July and August, pretty high values. Then it drops down quite low in January and December, January into February, and now has started coming back up again in the spring here. So those are the daily values. Then it sums those values, and that's what into a cumulative, and that's what the green line with the shaded area is. So The total amount here, maybe it's cut off a little bit on the right, that's in millimeters, so that's about 900 millimeters total, about 3 feet roughly of total evapotranspiration. So that would be applied irrigation plus rainfall to that site. So that's to me a pretty interesting thing to have access to data like this. Now, how accurate is this? Well, that I can't comment on because I'm not an expert in things like this. There's other people who can tell you far more. Later today, I hope that can tell you. And there's a lot of documentation online at this website that you can look into to really understand what is going on. But, like I say, it's available for you at no cost, and to me it makes a lot of sense to at least have it as a comparative value, too. If you're working with multiple blocks, you can compare between them and see how do they differ in these numbers. And then here's just a list of all the people involved in making that happen. So this isn't somebody working out of their garage putting together pretty pictures. I mean, it looks like there's some pretty heavy-duty folks who really know what they're doing. When you log on, it takes you to Australia to start with because it's an Australian consortium which is really making this happen, but in partnership with a lot of people here in the U.S. as well, and our federal government, USGS and NASA, to bring this information to us. Okay. Now, to come back down, though, to the cheaper reality here of what a lot of us in cooperative extension, at least us farm advisors, end up working with, is very simple technology that's much more robust and easy to use. And that's these little pressure switches that I've been employing for a number of years. So they're very cheap and reliable, and they can be installed in the site with very minimal disturbance or even the grower hardly even knowing that they're there. And that's the advantage that they have. They're not in anybody's way. It's not like installing a big flow meter where you have to be cutting pipes and things. This you just simply plug into the drip irrigation line. So what we're measuring is the pressure and recording the time when the irrigation system is pressurized on and then pressurized off. So we're measuring the duration that that system is basically operating. So if we're going to convert that into how much flow happened, we have to make an assumption, and that is that the flow rate coming out of all of those drip emitters is the same as what they were designed to deliver. So if you have a drip system with half a gallon per hour emitters, the assumption is that there's actually half a gallon coming out on average in the block. And you can have variability, but as long as the average is the same as that, then this assumption is pretty good. You can look back on some of the irrigation test data that people have done over time, and you can see some systems don't compare very well. Some are really out of whack. But I think for a properly designed and maintained and operated system, it's not a bad assumption. But that's, if you're using this yourself, you kind of have to be aware that you have to have a properly running system for that to be an accurate estimation. And many other devices, like soil moisture sensor devices, weather stations, if you're using the Thule system, they already have these pressure switches now added to them, so you can incorporate that into those measurements, and adds a lot of value. If you're measuring soil moisture, you want to know when the irrigation system was running. If you're using the Thule, it adds a lot more value to have information on when that irrigation system was on to then understand the numbers far better. So you may not have to do what I was doing here. But this is just what they look like. So on the left picture there, the pressure switch is inside that white housing. It's just it's about the diameter of a strawberry, so it's not very large device. And it just is connected into the drip system with this 1/4-inch line here. It just plugs right in. And then that pressure switch is read by a small data logger, a little hobo data logger, which is up in a waterproof container covered in tin foil up higher on the vine here. So that's the setup. And that will run autonomously for at least a year before it has to have a new battery put in. So it's like a little employee out there just reliably measuring things. As long as it doesn't get knocked off by a machine, it works very well. Now, in my work, I was measuring the drip systems, but we also had some sprinklers in some of these vineyards, so I'd have to have a similar device plugged into the sprinkler system, the frost sprinkler system, and that's what's going on in the picture on the right here. So that was a riser for flushing out the sprinkler system. I just simply cut the line, put in my own little coupler here, and attach the device to that. So a very easy thing to do, and nobody complained about me having to do that. Okay. So what does that provide you? So when you download the data into the little Hobo software program and you bring up a chart, this is what it produces for you. Okay, so maybe a little hard to see, but where there's just basically two lines. There's a base line here and then an upper line. So when the system is off, the line is at the base, and then when the irrigation system turns on, it comes up to the top line here. So these, what you see are just sort of little peaks and valleys. So the peaks are when the system is on, the valleys are when it's off. Okay? And you can see some very narrow peaks. Oftentimes those are just when systems or valves are being opened and closed and you temporarily pressurize the system, maybe just for a few seconds, and then it drops back off, or for a minute or two. Those are recorded as these very, very narrow little lines. But primarily the duration here is like several hours, 5 or 6 hours it looks like, that those systems are on. So if we look at the raw data, though, that comes with it, this is really what we use to then understand and do some calculations. So the data logger spits out, all it is a series of time values like this, and then the 1 in the irrigation means that that's when the system was pressurized, that's when it was turned on, the 0 is when it was turned off. So look in the red value here, you can see it turned on at about 10:30 a.m. and then turned off about 4:53 p.m. So a little over 6 hours of runtime. So just in this spreadsheet, I set this up and pull out those numbers. It's actually very, very easy then to pull out this data from the Hobo software data. And then above there, you can see here's an example where the system was just on for 1 second. So it's pretty easy to parse those out when you are doing the analysis. Okay, and then the other issue that I ran into before I could put all these devices into private growers' fields and be collecting their irrigation usage data, I had to assure people in my area that I was going to maintain anonymity of their data. That was a big concern. We currently have some lawsuits underway. They have been for a number of years, fighting over water, and that's just a reality in many areas. And the last thing that people wanted was perhaps their data being inappropriately shared in a way that they didn't want to. So I had to come up with some type of protocol that if I'm measuring things in their fields, that I would then be able to hide and not make their data available. And part of the challenge for me is that if I receive, let's say, a subpoena to provide data for a lawsuit or something, I have to comply with that, with all the information I have. So I have to make sure that I don't possess information that could be damaging to somebody else. So I just basically had a protocol where when I collected the data, it was identified by a code system, and then when I processed the data, I would then destroy the sheet that identified which device came from where, and after that I could not, even myself, go back and identify which data came from where after I had done that initial calculation. So that puts some big limits on me now, though, because I didn't know about that IRRISAT data until after I did all my calculations. Had I known that, I would love to have done some comparisons with that data. But after having done this processing, I cannot now go back and do that. But still, it would be a good thing to try to do if I'm doing work like this in the future, to know that in advance. The problem is that it puts you having to do a lot of work in a short period of time. But there's some other ways around that. Okay, so the work that I had done here in the Paso Robles study, that was from 2010 to 2013, 4 years of data looking at irrigation usage in vineyards there. Just there's the link to that article there. You'll have it on the handout that you get later if you want to follow up on that and get more information. But just as a summary, so in the 2000s, so a bit over a decade, 15 years ago, the big concern in the Paso Robles area was groundwater declines that were being observed in the groundwater basin area east of the city of Paso Robles. Now, the city of Paso Robles is here on the left, and the groundwater basin is what is this darker shaded area here. So it's a much larger groundwater basin, but a lot of the vineyard areas were concentrated in this region just to the east of the city of Paso Robles. So that's where this study was focused. So each of the black dots is a vineyard site where I installed one of these irrigation sensors. So there's a total of 84 properties that were involved, that volunteers that let me do this. And then along with that, put out rain gauges. That's the red colored dot, so a total of 7 rain gauges throughout this area as well. So it's a fairly concentrated area, which the weather conditions within this region you would expect to be very similar. So it's not like we're taking measurements in drastically different areas, so a fairly uniform area. And just to give you an idea then of what the total overall data looks like from those 4 years, that's what these cumulative irrigation application charts are showing. So each one of these lines represents the average cumulative application of irrigation for that set of 84 vineyards in the area. So what you see are very different levels of application from one year to the next. So 2011, that's the lowest line here, put on a little bit over 8 inches total of irrigation in that whole calendar year. 2013 put on the largest amount, over 14 inches of irrigation. Can anybody think why from one year to the next people would be applying more irrigation or less? Yeah, rainfall. I knew somebody would come up with that. So clearly people are responding to weather conditions as you would expect, but it's interesting to see how big those conditions are, how big those differences are. But one thing you'll note when you look at these lines is that irrigation starts at different times in different years, starts earlier in the drier years, and there's a lot of irrigation here well before bud break. That's a thing in my area that we often have to do in a dry year. Dry soils in the winter and spring are a bad thing for the vines. Definitely at bud break, we want to have soil moisture available to those vines so we don't get impeded growth. So there's a lot of winter irrigation going on here. That's one of the big reasons why we have more water applied in dry years. It's because pre-bud break irrigation. I think a bud break here about April 1st or later, there's quite a bit of water has already been applied in those years. But when you look later in, say, July and August, the slopes of those lines are all quite similar. So once we get into the main irrigation season, we're putting on about the same amount of water per week in this area here, because that's why the lines are all parallel. So there's not much difference from one year to the next when you get into that period. That just might mean that our weather conditions are fairly similar, or that people have habits that they stick with. But now going back to the connection between how much irrigation we apply and how much rainfall there is, let me go back right here real quick. If you just look at the total amounts for each of those 4 years, so that would be the final number on that cumulative chart, we can then plot that total amount of irrigation per year as compared to how much rain fell the previous winter. And that's what this chart is showing. So the bottom axis, how much rainfall in inches the previous winter, and then the vertical chart, how much irrigation in inches were applied the following calendar year. So you can see a pretty clear relationship. The more it rains here, the less irrigation is applied, and a fairly straight line through that. So this was an awful lot of work for 4 years to make these 4 little dots, but if you're the person who's being requested to manage groundwater and come up with an idea of how much irrigation is needed in vineyards based on weather conditions, this is a golden chart for you. Now, I took off the equation that goes with it, but there's, of course, a simple equation that describes that line, and then you can then make your own predictions based on how much rainfall you get, how much irrigation is going to have to be pumped to maintain vineyards in the same way that we do. So this kind of relationship really has lots of value, and if you're a modeler trying to understand, for example, how water usage might change with changing climate, this could be a good tool to have as well if you're trying to predict what happens if we get more or less rainfall in an area. I think, though, we can also extrapolate this and maybe apply this to other areas outside of my region, assuming that the grapes are grown in a fairly similar manner. So Temecula, if any of you have driven up that far from there and you're on the drier end of the scale, perhaps your irrigation applications might fit up here on that upper side. Talking to colleagues up in here in the North Coast, say Napa Sonoma or Mendocino, we get a lot more rainfall in some areas. These irrigation amounts seem kind of reasonable in those areas as well. So this might be sort of the starting point of a larger coastal irrigation requirement relationship, that as we over time can fill in some data points here with measurements in other areas, that might help this be a better tool for other people outside of just eastern Paso Robles area. So that is something to look forward to. So another way then to process the data from this study is to make a summary chart like this. Now this now relates evapotranspiration data and the irrigation application into a single, what you might think of as a recipe for irrigation. So what we're looking at here are each month on the bottom axis, January through December. This is an average of the 4 years. And then the vertical green lines, that's the reference evapotranspiration per month in that area. And the shorter blue lines, that's the applied irrigation that people put on. Okay, so again, if you have no data to work with and you've been moved to that area and understand how much to irrigate, this could be a starting point of how much irrigation you might be required for a vineyard. Another way to look at it, if you didn't want to measure how many inches to apply, you could just measure reference evapotranspiration And then from this line up here, this red line, that's the percentage of reference evapotranspiration that was applied as irrigation. So we get our reference evapotranspiration from a local weather station or CIMIS, and then you simply take that percentage of it. So let's say around here, roughly 15% January, February, March, up to 20% April, about a little over, let's say 2% in May, and so on. That would be another way to understand how much irrigation to apply. Now, chances are this is not the perfect amount for any site, it's just the average of all sites. So keep that in mind. This could be sort of a starting point to understand how much to irrigate. So it's when you present simple, clean lines like this, sometimes it gives you the sense that we understand things maybe a bit better than we actually might. So let me kind of pull back the curtain a little bit and show you what goes into making these lines. So back to our cumulative irrigation application charts, we just look at the 2013 line here. I'm going to show you now the data that went into making that. And that's what it looks like. So clearly, it's not that everybody in the area is irrigating the same and it happened to make that nice, clean, average overall line. People are irrigating very, very differently, and maybe for good reason, but maybe not for good reason. That's kind of what we're trying to figure out. And I should point out that all of these sites were essentially in an area that had about the same reference evapotranspiration and same rainfall amounts. So what kinds of things could be causing people to irrigate over twice the average or less than half the average? A number of factors you can probably think of. So for example, if you have a coarser or shallower soil, or growing a very large canopy, producing a very large yield, or have a cover crop that you allow to grow late in the spring that's depleting lots of soil moisture, you will need to be on the above average side perhaps because of that. Or conversely, if you have a finer and deeper soil that stores lots of soil moisture from the winter rainfall, if you're growing a much smaller canopy with a much smaller yield, or you're not allowing that cover crop to grow, or you're stopping this growth very early, you're conserving more of that moisture for use later, so perhaps you can get away with applying less than the average yield. But what I don't know is, are these being done intelligently and with a purpose, or is this somebody making a mistake by doing this? So that's the kind of thing that hopefully having this average value, people then hopefully will know more or less where they're at. If they know they're up here twice the average, that might at least give them reason to look at what they're doing and understand. Hopefully they're making that decision with a purpose. If not, they can reevaluate. So this picture just sort of demonstrates, though, that even within a very small area, you can have vineyards that have very, very different water requirements. Clearly these two blocks right next to each other, same soil, same climate, same weather conditions, but very, very different irrigation needs, just based on the size of the canopy, which I guess Larry Williams stayed out too late last night, but if he was here, he would then chime in and say, that this clearly has a much bigger light interception, much larger midday shaded area. It's going to need far more water as irrigation than this much thriftier canopy on the right here. So that's our understanding. We know that this is going on. So there are good reasons, again, why certain blocks might need far more water than others. If one is going through the trouble to measure data like this, it would really be nice to add value to it by measuring other things in a region. So, for example, that previous chart showing the wide disparity in how much irrigation people are applying, maybe that's related to soil parameters. Soil survey data or local measurements on site could add a lot of value to help understand that, but that comes with a lot of work needs to be done to get that information. Soil moisture levels, how wet are people keeping the soil? That has an influence on the amounts that people are applying. The estimated crop coefficient values, that's indicator of how large these canopies are or how small they are, that would help us understand irrigation application. Crop yields, I would have to get that from a grower, but if they were willing to provide that, that also could be a good way to then judge whether or not these extra irrigation applications are being done with a good reason or not. But that's a lot of work to get that. The other issue, a lot of us in the southern part of the state where we're using groundwater, sometimes that groundwater does not have the best quality, have salts and things that we have to manage, so sometimes people are putting on more water to manage that salinity. So that would be good to know in these comparisons. But again, far more data needs to be collected here. So just measuring the irrigation usage with those little automated pressure switches is relatively easy. Trying to get all of this extra information is a lot of extra work. So that's part of the challenge to add value to this. But however, we're still proceeding forward with more work like this. So I've got a couple of different projects in San Luis Obispo County that I plan to implement, also in vineyards down there. I was actually hoping to do some work in hemp this year, but then UC decided to not let us do hemp research out in private fields. I can only imagine why. We'd all be leaving with duffel bags, perhaps. I don't know, but that clearly was not going to happen with me. I was just going to measure water use. It's a good idea. As we transition to other crops in other areas, we have no idea how much water they might need. So collecting data like this is one way we can start gauging that as quickly as we can to help understand how these new crops might impact groundwater basins if we have people shifting from one crop to that new crop. So there's really no other way to get that easily. We got funded with my colleague Rhonda Smith to do a similar study up in the areas of Sonoma County, and that should be in place later this year as well. But one change I do want to make as I'm doing this, I mentioned that one limitation is when I have to go out and collect the data every year and anonymize it, once I have that data collected, I can't go back in time to get data from those sites. I can't do any follow-up measurements. So I'm changing my design a little bit. I want them just to run for 4 or 5 years without me having to touch them, which I achieve by just putting large batteries on them and sealing them up very well. And my goal is plant them like a potato or something, let them sit there for many years, and then dig them up later, collect the data, and all during those years I've been collecting a lot of that other data, which will help us understand the environment that much better. So hopefully that'll work. Now, one other thing, okay, so imagine you are in an area, you have now a groundwater management agency created, whether you like it or not, created to manage groundwater, and they have to collect a lot of data in that process to understand the system. Can that data that they're collecting, let's say they're collecting data from well flow meters. Their use, they want to know how much water is being applied in the year or something, but if they're collecting this in real time, live data, can they kind of turn it into some of the data that I showed you to give you a value that you might be able to use for understanding irrigation needs? So maybe there's a way to take this data and use it live, more or less, as an irrigation management tool. And that would be a really neat thing to be able to do. And so here's kind of the way I look at this. This sort of goes back to covering why we might want to measure data like this, even though we know that people are using irrigation in a widely different manner. Does the collective knowledge of this add value that we might not otherwise have? And perhaps you've heard of this whole issue, the concept of the wisdom of the crowds. If I asked all of you how many jelly beans are in this jar, the idea is that not one of you would guess it just right, but if we averaged all of your guesses, that average might be pretty darn close to the 189 or so that are in that jar. I don't know. But that's kind of part of the idea here, is that if we collect all of our decisions and then average them, that information might provide value to all of us, and just understanding what all of us are deciding is appropriate for a system. And the bottom chart here is maybe a way to look at that wide disparity in irrigation usage, that maybe people kind of more or less in the middle are doing okay. They're applying maybe the proper amount, but people on the extremes, there may be people applying too much and they're not aware of it, or people on the lower end applying far too little and they're not aware of it. Having this data could be a way for them to improve that understanding. And this is kind of how I just want to show you in my area, in my experience. I started in 2001, and so I've seen some transitions in my area over time. I just want to show you how, in my experience, the conversation has evolved in the area. So when I first started, all the discussion about irrigation was how many hours per week you were going to run your system. That's what I heard people talking about. People still do. That's still a useful currency to understand irrigation. But it's a fairly simple one. It doesn't incorporate weather conditions. It doesn't incorporate lots of things that we now know we need to include in that. So over time now, instead of just talking about hours, now people are talking about tools that they're using, methods that they're using to try to gauge irrigation uses. So now we have people looking at vines more closely, measuring soil moisture far more commonly, actually incorporating ET or pressure bombs or pyrometers or whatever tools you might think of, trying now to base irrigations on some actual data that they're collecting in the field. So maybe going forward, if we are collecting data like this, the groundwater management agencies over time, and if they can then display this data in real time as, say, weekly amounts of irrigation applied on average, that could be a value then that growers look at to kind of gauge where they're at. So a grower might think, well, I can just apply more or less that amount 1 times that index value, and that might realize that they're pretty happy with that. Others, for example, if he needs a bit more crop, he might need to add a bit more water to get himself into the realm of where he wants to be. Or you can think of other reasons why they want to be in different amounts. But again, it's just, if we're collecting this data already, or if we're being obligated to collect it, is there a way to turn it into something that we can then make use of as an industry? And I'll kind of leave you with my last little concept here. This is a depiction of a farmer driving along in the morning on his way to work, and asking himself, well, how much irrigation do I need to apply this week? We make that decision based on many things. So we're observing vineyards visually, past experience from a site. We're talking to other people, getting some input from them. Educated guessing, clearly, a lot of that has to go on, and some measurements in the field. And you'd think that on a normal day that might be enough to make a good decision. The problem is these same people have a lot of other things they're having to do. So it's not like we can just focus on making the irrigation decision. We have all these other things about managing the vineyard, managing the business, which oftentimes become a far, far more important thing day to day. We can't let the weed problems or the disease problems get out of control, but it's a little easier to not have to spend the extra time to calculate irrigation if we kind of have an idea of what we've done in the past. So there's reasons why we sometimes spend less time focusing on the irrigation simply because we have to spend more time on other things. So any tools or information that we can add to help this process, I think we definitely would like to take advantage of. So that's all I have for you. How are we doing on time?
Good.
Okay.
We have time for a few questions. Yeah. Oh, you were? Yeah. Okay. Are there any questions? I have a question.
Oh,
so
please.
Have you observed that large variability every year, or the one that you show in 2013?
Yes, yeah, and that's pretty consistent. I just only plotted that one to show you, but that's something you would expect.
Okay.
Yeah.
And do you have a sense whether in your area people use like visual observation, or they go with mainly some tools, soil moisture to schedule irrigation?
We have a bit of everything. So I think like most regions, there's some people who like to base on soil moisture measurements, other people who are using ET data, a lot of people still on just visual evaluation and their own experience at sites. As was mentioned yesterday, that people with enough attention to things can make just about anything work for them, provided they put enough of themselves into those measurements and really stick with it. So there's lots of tools that can work for people. Yeah.
Mark, you mentioned anonymization a couple of times. This is obviously a really loaded question from my side, but is it reluctance on the farms side to capturing data? If you could provide them an assurance of anonymization, would that open up more avenues for you, or is it we don't want any data taken off our phone?
No, that's a great question. So if you didn't hear it, are some farmers reluctant to let data be measured because they're concerned about that data not being anonymous? I think if you can guarantee anonymity, that really helps farmers want to cooperate that much more. But this may be a thing that over time we become less concerned about for some things. That Irrisat website that I showed you, you can't hide what you're doing. So let's say you're the farmer who's putting on twice as much water as everyone else. That website's going to show it. So I didn't mention, but tools like that are what a lot of these groundwater management agencies are going to be using to understand how much water is being used where. So there's things that we can't hide from. You keep that in mind. You can't block that satellite view from your field. Yeah. Okay.
But that's ET, it's not applied water.
Exactly, but they're related. We can infer one from the other.